2. I got a couple more problems to do here on 6.2. It says, find a c in this interval, which is the average value of this function. So what does this look like? Square root of x, something like this. Starts at 0, 0, 1, 1. Square root of 4 is 2. And if you go clear out to 9, the square root of 9 is 3. And if we're going from 4 to 9, it's going from a height of 2 to 3. So the average value is somewhere between 2 and 3. To get that average value, you take the width of the interval we're doing, 4 to 9, which is 5, and divide the area that this is by 5 to find the average height. The area would be from 4 to 9 of the integral of this function, dx. So integrating that, we get 1/5 x to the 1/2. So we add, so that's 3/2, 2/3 x to the 3/2. Evaluated from 4 to 9, which is 1/5. The 2/3 can come out, so that'd be 2/15. 9 in there. Square root of 9 is 3. Cubed is 27. Minus 4 in there. Square root of 4 is 2. Cubed is 8. So 27 minus 8 is 19 times 2 is 38/15 is the average height, which is 2 and 8/15. Okay? Somewhere between 2 and 3. 2 and 8/15. So then, we're supposed to find out at what value. There should be some place in here, some c, where this curve is actually that high. So we have to solve for x, where the square root of x is, because this is the height on here, is 38/15. So we would square both sides to try to find that x, and we get the x, the c that's in here and here, should be 38/15 squared. Let's see what that is. It should be a number between 4 and 9 that has that height. Let's see if we find that. Parenthesis 38 divided by 15, close parenthesis, squared. 6.417, approximately 6.4177. The exact value is this, but here's the approximate value, and now we can tell whether it's really in between 4 and 9. Yes, it is. Out here, 4, 5, 6, 7, 8, 9. So it's about here, where it's just where I kind of estimated it to be. Okay. And this one, which has the larger average value? Sine squared, sine curve, sine squared is going to go, the small, it gets up to 1, so small numbers are going to go kind of like this, and then it's going to do something like that. These numbers that are smaller than 1 squared go even lower. If you take this times x, well, x is 0, x is 1, it's going to be something like this. going to bring this down, and then it's going to kind of do something weird here. When you do it times x squared, these between 0 and 1, this is smaller than 1, and that's going to decrease the area of the square, where, or is going to, smaller than 1, it's going to decrease it, but something smaller than 1 squared is going to be even smaller. So like if x was a half of this, here a half squared is a quarter of this, so this is going to have the smaller value between 0 and 1. And between 1 and 2, this is bigger than this, so this will have more area than that. This will have more here, this will have more here. Okay? Because numbers between 0 and 1 squared are smaller than this, but between 1 and 2, this is bigger than this. This is bigger than this here. This is bigger than that there. That's it.